Hello, this is Albert van Dijk, and this is a brief video about altimetry and its use for water and ice studies. So one of the main uses really of altimetry is to measure ocean level variation, and that is partly because we want to know where currents are going and how El Niños are developing and so forth. But it's also to look at over time how sea level is rising or falling from year to year and from month to month. And so there's quite a few radar missions that have been and continue to be to try and measure that. And this graph here is constructed using some of those radar satellites. And going back from 1993, we can clearly see the increase in global sea level here in millimeters to about 50 millimeters. And if I was to extend this, it would go back up again, somewhere around 50, 60 millimeters since 1993. You can do the same thing though for inland water. So you can measure the height of lakes, for instance, and that's what this website here does. The Crop Explorer. It shows you the water height variations compared to the average for a number of lakes in the world. And knowing that can be quite useful, particularly when downstream there are important irrigation areas that rely on the amount of water in those reservoir lakes. Here's a particularly dramatic example of radar altimetry being used to basically see the demise of the Aral Sea. So starting from 2 meters above some arbitrary reference level, the lake has been falling steadily ever since the 90s and is basically sort of flatlined now because it's almost dried up, having fallen about 7 meters or so. One of the challenges with radar altimetry, as with most remote sensing instruments actually, is that they don't spend too much time in orbit. So they have to be replaced with new radar altimeters, and so you end up with a series of altimeters, and those records need to be combined into one single record. And that's easy enough if you're looking at a very large water body, but if you're looking at a relatively small water body, that can be quite difficult. You might see that water body is not observed by all those, by each of those missions. Here's an illustration of that, showing the tracks of 3 different altimeters. You see here in blue the Topex Poseidon, the RS, the Geosat. And as you can see, their tracks don't lay on top of each other exactly. The orbits of these satellites are a little bit different, and so they don't measure the same water bodies necessarily. So one of them, like let's say here, the red line is you see crosses this water body here, but some of the other ones do not, and so you might not be able to have a continuous record for water bodies. And that's a bit of an issue. Works a lot better with big rivers, as you can imagine, like the Amazon is big enough, and it's also got a nice feature that it goes from west to east, which means that a lot of these tracks will cross it. So you see in colors here, gauging stations, if you like, satellite-based gauging that is of water levels. And to give you an example what it looks like close, you need something of this sort of size to be able to get a good radar altimetry measure. And here's another example of where the river is broad enough and big enough for the altimeter to give a good return. And if you do have that good return, then you can see quite clearly the seasonal variations in water level. And of course, the Amazon is nice in the sense that the water level variations are quite enormous as well. Going from 22 meters here to 14 meters here. In other words, some 9 meters variation. Well, even a lousy altimeter would be able to measure that. In some other rivers, it's not so easy. Might only be talking a few centimeters, and then you start to really get close to the or beyond in the accuracy of the radar altimeter. And so the great advantage of altimetry is that in reality, you will only be able to put gauging stations at a few places. Those are the squares here. But with altimetry, you can really extend that network with virtual gauges, if you want to call it that. All right, finally then an example of altimetry, and in this case a LiDAR altimetry with the ISAT satellite to measure the surface changes in the ice sheets. And you can do this over glaciers, but in this case you see it over the north and south, the Greenland and the Antarctic ice caps. And you can see in blue areas where the level's been going up. In other words, presumably it's been gaining ice. And in red you see those areas where we've been losing ice. And as you can see, that's quite detailed information. It's very hard to get in any other way. So another really useful use of altimetry. All right, well, that was a short video on altimetry for water and ice studies.